First, we need to prove that this point A lies on the line L. And to prove that, I'm going to make use of the position vector of A, which is minus 2, 23, and 33. And I'm going to let this be equal to the equation of the line L. So if I were to let this be equal to 10 minus mu, minus 1 plus 2 mu, and minus 3 plus 3 mu. My aim is to try to solve for mu and showing that the mu is consistent for every single row that I have here. That means every single row that I have is going to form for me an equation in terms of mu. For example, from the first row, I will have minus 2 plus is equal to 10 minus mu. And this will help me to solve for the value of mu, and mu is going to be equal to 12. From the second row, we have a 23 is equal to minus 1 plus 2 mu. And if I were to solve for mu, bringing this over 24 divided by 2, mu is again equal to 12. And for the last row, 33 is equal to minus 3 plus 3 mu. So mu is going to be equal to 36 divided by 3. It is once again equal to 12. And since all the three equations give me a consistent value for mu, that is why I can say that A lies on the line L. And this line L, from the previous part of the question, we know that it is perpendicular to P. And since we have now a point B, which is a mirror image of A in P, B is also going to be lying on the line L. And in fact, it can be somewhere that is, let's say here, this is point B. And since it's a reflection, this length is going to be exactly the same as this length. Okay, and of course, AB must be perpendicular to P. That is why we have concluded just now that B is going to be on this line L. And in order for me to find the coordinates of B, I'm going to make use of the ratio theorem. And if you were to revisualize this, we have point A, we have point B here, and I know what is this point. This point has a coordinate of 17 over 2, 2 and 3 over 2. Point A has a coordinates of minus 2, minus 2, 23 and 33. And the proportion here is going to be 1:1 since this length is the same as this length. And if I were to now reference all this to the origin, I'm going to make use of the ratio theorem to form an equation in terms of the vector OB. So making use of the ratio theorem, that means 17 over 2, 2 and 3 over 2 is going to be equal to this multiplied by OA. So 1 times of OA, which is minus 2, 23 and 33, plus 1 times of OB divided by the proportions added together, 1 plus 1, which means that OB is going to be 2 times of 17 over 2, 2 and 3 over 2, minus away minus 2, 23 and 33. So OB is going to be equal to 19, minus 19 and minus 30. That is why the coordinates of B can be expressed as 19, minus 19 and minus 30.